pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Okay. So, we had the homework assignment and we need to finish up what we're talking about. So, we know that hydrogen is definitely a fusionable fuel, what powers the sun. We also know that hydrogen is capable of reacting with oxygen to produce H2O. It's highly flammable, so it's also a chemical fuel. So the question is, this reaction, we have virtually a limitless supply of fuel, and the answer was fusion, because we can get all the hydrogen we want from water. So why isn't the answer also therefore for chemical? I mean, why wouldn't we say we virtually have a virtual limitless fuel supply for a chemical reaction too? Maria? What do you mean there's a bunch of, I don't understand what you mean. When hydrogen burns, that's the reaction.
Yeah, that's not the only chemical reaction, and the other ones we don't have limitless supplies of, but they reactions.
You mean like gasoline?
Sure.
Okay, no, I'm just simply saying, can we say that we have virtually a limitless supply of fuel for the hydrogen combustion reaction? So I'm making it more specific. I'm ruling out. So if that's how you were interpreting it, I'm ruling that out, that option out. The answer is still no. Michael?
It's because most of the hydrogen on Earth is not in the air, but it's bonded to the oxygen in the water. So in order to actually use that hydrogen, you have to separate the hydrogen and the oxygen in water, which would be the reverse reaction of what you're intending to do.
That's the answer. Do you guys understand? In order to get the hydrogen to burn, where do we get it from? Well, we have to take the water and we have to break it apart to get it. Well, that means that the energy we get here, we had to invest to get it here. So it's sort of a no-win situation. It doesn't really lend itself well as a fuel from that sense. But what about fusion? Don't we have to get the hydrogen? Don't we have to do this too? Don't we have to take the water and break the hydrogen down to get the hydrogen so we can run the fusion reaction? Yeah. Why isn't that an issue?
Because the hydrogen goes to form a different product.
So, Carrie?
More energy is produced than is needed.
We get a ton more energy from this than what it takes here. This is like you got to pay a penny to get $1,000. Okay? This is nothing. But in a chemical reaction, it's a no-win situation. Do you guys understand? Okay, we have virtually a limitless supply of fusionable fuel, hydrogen, which we can get from water. So that's a true statement. Because even though it costs us energy to get that hydrogen from the water, the amount of energy we have to invest is a mere pittance compared to the energy we're going to get back from the fusion reaction. In a chemical reaction, the energy we're going to get back is the energy that we put in the first place. So it really doesn't pay. We can't really say that we have a limitless supply. Questions? Yep.
Could wood not be used for a chemical reaction? Since burning wood is a chemical reaction.
Yeah, that's...
And would you not say we have limited or an unlimited supply of trees since we can replant them?
You would be hard pressed because it's not a very efficient fuel. So you would be hard pressed to do it. In fact, if you go ahead and look at countries in terms of, you can tell, countries that are really poor in resources will resort to burning wood, burning dung, manure. as a way of generating energy, and it's a really lousy way of doing it. It's not very clean, so it's not good for the environment, and it's also not very efficient either. Yep.
For the virtually limitless supply, couldn't we like say like everything that's a fuel is part of the supply? So wouldn't it be like virtually limitless since a lot of things can be fuel?
Well, what we're talking about when we say virtual limitless supply is we would not run out. Okay, you're going to run out of. I mean, there's a limited amount of oil in the ground. Is it something you or your grandkids have to worry about? No, but I mean, there is a limited amount. Same thing with coal. Same thing with natural gas. One could argue, well, really, as far as you and I are concerned, or our immediate descendants, yeah, it's not really a big deal. But hydrogen, yeah, there's no way we're going to run out of that because 3/4 of the planet's covered in water. So it's just from that perspective. Other questions or comments? What about the next one? Main reaction in nuclear weapon uses would be what, Joe?
Fission.
That is not correct. Guess again.
Chemical.
The main reaction a nuclear weapon uses is chemical? No.
I don't know.
Well, let's see. You've ticked off 2 of the 4 choices, and they weren't right. Care to try a third time?
Fusion.
There you go. Yeah, fusion. Joe, fusion is so much more fuel efficient over fission. The first atomic bombs, the first nuclear weapons, the atomic bomb, that was a fission-based bomb. Okay? But when we perfected it, then we got to the point where we could do fusion bombs, they blow them away. That's why today's modern weapons are sometimes called hydrogen bombs. It's because it's fusion-based. Okay? Questions? All right, this is the reaction used in the atomic bomb during World War II. All right, Joe.
Fission.
Pardon me?
Fission.
Fission is correct. There you go. And this is the reaction used in the bombing of Iraq. And that would be what, Hunter?
Fusion and fission.
Oh my God, no. No. Maria?
Fission.
Oh my God. Oh my God. Ada? Chemical.
Oh yeah, we didn't do that.
Yeah, we did not nuke. Guys, we did not. Look, the only time a nuclear weapon has ever been used in warfare was in the bombing of Hiroshima and Nagasaki. And that was and it's still a very controversial move. It could be argued to save countless millions of lives on both sides because it brought a quick end to the war. Yet it also has ethical concerns as well. We'll leave that to the philosophers or the debaters to debate at some other time. But my point is that's the only time nuclear weapons have been used in warfare. Okay? Now, that means that every time you see in the movies, okay, or every time there's a real war where there's explosions going on, those are chemical-based explosions. Things like C4 and dynamite, TNT. Okay, those are based on chemical reactions. Please understand that when we bomb in the bombing of Iraq, when we say the reaction of those explosions was chemical-based, that does not mean we use chemical weapons, okay? That's something different. A chemical weapon is a chemical agent that will go out and, kill someone because of the toxicity, because it's poisonous. That's not what we used, okay? So when I say it was chemical-based, I mean the explosion was chemical-based, not that we use chemical weapons. Just to be clear, since some of you apparently thought we were using nuclear weapons. Questions? Okay, all right, so that takes care of those two sheets, so that worksheet. Let's turn our attention to worksheet 1, Atomic Theory Part 2. And now I'm just trying to remember. Yeah, so this is the one I did. Okay, so you did not have a key for this one, right? Okay, so let's just go through it. Give the Rydberg equation, explain what its use is. So you should have given me 1 over lambda is equal to 10.9.678 centimeters to minus 1 over n sub 1 squared minus 1 over n sub 2 squared. You do not need to actually, if I'm asking you for the equation, you can put an R in place of it. You don't have to actually show the units, but the reason I'm including them is because on the test, if you work this equation out, you've got to know what that R value is, and you've got to know what the units are so you know what lambda turns out to be. So that's the equation. What's its use? Samantha?
It predicts all of hydrogen's line spectrum wavelength.
There you go. And the specific, be specific though, what portion of the EMR spectrum?
Visible,
And
ultraviolet,
And
infrared.
there you go. Yeah, it predicts the wavelength for all of the lines in hydrogen's infrared, visible, and ultraviolet line spectrum. Yes.
So there is line spectrum for like X-rays and microwaves, but that equation.
We're just not. Yeah, we're just not. The substances are capable of absorbing and emitting wavelengths outside of those three. Yes. Other questions? Okay, and number 2, it asks you to name the 5 series of hydrogen line spectra, identifying the portion of the spectrum that each series covers, and then finally give the n sub 1 and n sub 2 values allowed for each series. In other words, I'm asking you to be able to reproduce what, Matthew?
The chart,
The table found where?
first page.
First page is the bottom, guys. You guys understand? Okay, that's what you need to be able to reproduce in order to be able to do this. Any questions so far? Joe?
What's the name of the last one on the table?
It's pronounced Fund. P-F-U-N-D, Fund. And n sub 1 value would be equal to 5, n sub 2 values 6, 7, up to infinity. Other questions? Yes?
Whenever we have a problem dealing with like the table, are you always gonna tell us line 3 in brackets, or are you gonna be like high infrared lines?
If I were to, yeah, okay. So if I asked you to find the wavelength corresponding to the third line in hydrogen's ultraviolet region, then that, since there's only one series that deals with it, the Lyman series, I'm basically telling you find the wavelength for the third line in the Lyman series, right? So that shouldn't be a big deal. Same thing with visible. For infrared, I actually have to name the series because you don't know which one I'm talking about. Other questions? Okay, number 3, what's the significance of Rydberg equation? So what's the big deal about this? Why is it so important, Juliana?
If the equation,
Yeah, what's the big deal?
It's, they found the mathematical relationships regarding line spectra, so it's not random as we previously thought.
Okay, so number 1, and it's not to say that they thought it was random, it just appeared to be. So number 1, this equation is significant because it affirmed that there was order or logic behind line spectra. Okay, it's significant because it affirmed, okay, where it showed that there was some kind of order or logic behind line spectra. As Julian said, that's a bit of an issue because it does look pretty darn random. Anything else? Julian?
Anything else significant about it?
Yeah.
I don't think so.
Yeah, no, there's something else. All right, Noah.
Future theories have to include this.
What do you mean fusion?
Future theories of the line spectra has to
Say
include
again?
equation.
Future
Theories must include the
future theories